All right, moving on to the 7.4 notes, some more with function notation. So the lesson objective here is that you should be able to evaluate a function written in function notation. Now, in the previous lesson, you were given the function in terms of an equation. So now here we're given values that are in a table. So let's make sure we understand how to read this table. So highlighted here is this column where on the very top of the column we see an x. Right? So all these values down this column represent x values, again, which for us means the domain, which for in terms of functions means that these are the input values. Right? So again, the x's in this column, these x values represent the inputs for our function. Along the top of the chart, here I have highlighted, you see function notation. You see f of x, g of x, h of x, and j of x. All right, so again, this is clearly function notation. But we need to remember that this function notation represents the range or the outputs for our function. Okay, so every value going down each of these columns represents the outputs for these four different functions. So now we need to understand how we're going to put everything together in terms of what we've seen in the previous lesson. So you see here, I first highlighted the input value of -2 with respect to f of x. All right, so in yellow is the input value, and in blue is the function. So what I highlighted in green, because yellow and blue make green, right, is that saying that this is the output value for the function given the input value of -2. Okay, so this is saying if I took -2 as an input, plugged it into the f of x function, the output would be 4. If I change my input value, say to 1, right, again, using the f of x function, we see that I have highlighted in green is the value of 1. So which is saying that if we plug 1 in the x column into the function f of x, the output would be 1. Now if I change my function, right, so keeping the same input value of 1, but now I switch over to the g of x function, if I want to know what the output for the g of x function would be, if I put 1 as an input, all I need to do is find the intersection of row and column. So wherever the input of 1 is, intersecting with the column of g of x, right? This is telling us that if we plugged 1 into the g of x function, 2 would be its output. All right, so with that, let's take a look at example A. It says evaluate g of 1. All right, so just like we did a minute ago, all right, we're going to go to the g of x function, and then we are going to go to the input of 1. The intersection of both those row and column is 2. The answer here is g of 1 is equal to 2. Let's find j of 3. We're going to start with the j of x function. and then we are going to look for the input value of 3. So where those two intersect, so input value of 3, go to the intersection of that and the j of x column, and that brings us to 4. Right. So our evaluation of j of 3 is 4. So now let's take a look at part D, where it's asking a little bit of a different question. It says if f of x equals 9, then x equals blank. So again, we have to remember, right, that the x values are our input and the output values are represented by the function notation. Okay, so for this one, we're going to start off by, again, looking at the f of x function. So we're looking somewhere down this row, down this column to start. And here we're given that if f of x equals 9. So now we're going to look for 9 going down this f of x column. F of x equals 9 is right here. All right. But it's not asking us for an output value for this problem. It says if f of x equals 9, then x equals. So we're looking for an x value. So that means we need to look, hey, what x value, what input value do I need to get this output value of 9? That would be 3. All right, so x is equal to 3. Let's see what you can do with part E. All right, so again, it's telling you if h of x is equal to 11, then x equals. So we're going to start by looking at the h of x column. So we're going down that column, and we are looking for the output value of 11. There it is. All right, so now we need to figure out what x value is needed for this function to have an output value of 11. So we look all the way to the left, and we see that value is 3. So if h of x equals 11, then x is equal to 3. All right, let's move on to example 2, where it says find the range of each function with a given domain, gather the ordered pairs, plot the ordered pairs, sketch the graph, and then label each graph. Okay, so we're only going to do one of these 3 functions. We're going to do function B, where it says g of x is equal to 2x squared, and we're given the domain of -2, -1, 0, 1, and 2. All right, so what we're going to do, we want to make a table, a good old-fashioned t-table, to figure out our ordered pairs for this function. All right, so one column is going to be our inputs of x. The other column is going to be our outputs, the g of x. All right, so now what we're going to do is we're going to take our each individual domain value, input value, plug it in for x in the function to figure out the outputs. All right, so there's all our output values, and so now we're going to pair them up to create our ordered pairs. All right, so now that we have our ordered pairs, let's go ahead and plot those on the graph. All right, so there's our points, and so now we're going to connect them, right, assuming that this is a continuous graph. Okay, so now be careful how you connect these dots, because these are not straight lines. All right, they should be curved, right? So you notice at the end of this graph, I do have the arrowheads, right? We're assuming that if we do create more points for this function, the graph would continue, right, in that particular direction. All right, so let's move on to the next page of notes. And so here we see, for example 3, that we have 3 different functions graph. Right, we have m of x, r of x, and p of x. All right, so we have three different graphs of functions on this same graph grid. All right, so now what we need to do is that we're going to be using the information from the graph to find the answers to the questions off to the left. All right, so the first one says p of 6 equals. Okay, so what we're looking for, we have to understand the notation, is that we are looking for the output value for the p function given the input value of 6. So the way we do this is we're going to first look for that input value of 6 along the x-axis. All right, so there it is right here. Right, here's our input value of 6. So now we need to go to the p of x function. So we need to go to the graph. So what we're going to do is we're going to take our pencil, our pen, our eye, and we're going to move our way up until we hit the p of x graph. So it's right here is what we're interested in, right? At this input value of 6, we are now at the p of x function. Okay. So what we're looking for the output. Well, the output values, again, are the y values. So that means from this point, we need to move our eyes, move our pen towards the y-axis. And when we do that, we see that right here, I know it's kind of hard to see, at this value of 4, that is our output value. Right? So again, an input value of 6, we go to the p of x functions graph, make a mark, and then we look to the left towards the y-axis to find our output value, and that output value here is 4. All right, so p of 6 equals 4. Now let's move on to b. M of 0 equals. So m of 0 means that we're going to first start to look at our input value of 0. All right, so that means we're right here on the x-axis. We're right here on the x-axis at 0. Right? And then we're going to make our way towards the m of x function. So now again, we need to go to the m of x graph. So now I'm not going to move up, because if I move up, I'm not going to hit that graph. What I need to do is move down, because this is where that m of x graph is, right here. Right? So here is the point that we're interested in, because we are on the graph and we are also on the y-axis. All right, so we're looking at that y value, and that y value there is -5. I know it's hard to read, but you count the boxes, right? That point is at -5. So that is our output value. M of 0 equals -5. Now let's see what you can do for r of 0. Okay, for r of 0, we need to go to 0 on the x-axis, because that's our input value. And then we need to make our way quickly towards the r of x graph. So we need to move up, and here we are. And we hit the graph, and we also hit the y-axis. So this is the point that we're interested in, right? At r of 0, the output value is a +5. All right, so now let's look at part D, where it's asking you, or if m of x equals 4, then x equals. All right, so for this one, we are going to the m of x function graph, right, but we're going to start with the y value, because they are giving us the output value of 4. We're going to start at the y value of 4, make our way towards the m of x graph, put our point right there. But this time, we're going to look down towards the x-axis, because we are looking for an input, and as we scan our eye down, we see our input value of -3. So x equals -3.